Hello and welcome to our class, The Application of Derivative, Newton's Method. We are considering the problem of solving the equation f of x is equal to 0 for a root r. Suppose that f is differentiable, so the graph of v is f of x has a tangent line at each point. If we can find a first approximation x1 to r by graphing or any other means, see this figure. Then a better approximation x2 or to line at the intersection of the tangent line at x1 f x1 with the x-axis. Using x2 as approximation, we can then find a still better approximation x3 and so on. The process can be mechanized so that it is easy to do on a calculator. The equation of the tangent line at x1 f x1 is that y minus f of x1 is equal to f prime x1 times x minus x1. And its intercept x2 is found by setting y is 0 and solving for x. The result is x2 is equal to x1 minus f of x1 over f prime x1. More generally, we have the following algorithm, also called a recursion formula or iteration scheme. We name it Newton's method. Let f of x be a differentiable function and let x1 be an initial approximation to the root r of f of x is equal to 0. Let E denote a bound for the error that the absolute value of r minus mm. Repeat the following step for n is equal to 1, 2, and so on, until that the absolute value of xn plus 1 minus xn is less than E. Here, xn plus 1 is equal to xn minus f of xn over f prime xn. Just now we talked about Newton's method. So let's do one example about that. Please use Newton's method to find the real root r of f of x is equal to x cubed minus 3x minus 5 is equal to 0 to 7 decimal places. Now let's solve it. First, let's use x1 is 2.5 as our first approximation to r, as we did there. Since f of x is equal to x cubed minus 3x minus 5 is equal to 0, and f prime x is 3x squared minus 3, then the algorithm is xn plus 1 is equal to xn minus this xn cubed minus 3xn minus 5 over 3xn squared minus 3. After just 4 steps, we get a repetition of the first 8 digits. We feel confident in reporting that r is approximately equal to 2.2790188, with perhaps some question about the last digit. Alright, after the example 1, let's see the next one. Use Newton's method to find the positive real root r of this function. The function is f of x is equal to 2 minus x plus sine x, and the equation is equal to 0. f of x is equal to 0. Now let's solve it. So the graph of the function is shown in this figure. We will use the starting value x1 is 2, since f prime x is minus 1 plus cosine x. Then we have xn plus 1 is equal to xn minus 2 minus xn plus sine xn over minus 1 plus cosine xn. will lead to the following table. So the table like this. And after just the 5 steps, we get a repetition of the 7 digits after the decimal point. We conclude that R is approximately equal to 2.5541960. Newton's method creates a sequence of successive approximations to the root. It is often the case that Newton's method produces a sequence xn that converges to the root of f of x is equal to 0. That is, the limit of xn when n goes to infinity is r. This is not always the case, however. So this figure illustrates what can go wrong. For the function in this figure, the difficulty is that x1 is not close enough to r to get the convergent process started. Other difficulties arises if f prime x is equal to 0 or undefined at or near r. When Newton's method fails to produce approximations that converge to the solution, then you can retry Newton's method with a different starting point, or use a different method such as the bisection method. Alright, that's all for this section. Thank you.